we're still in 3.1. We're still talking about lines. What we want to get to is applications, right? We want to get to application examples of linear equations. So when we talk about a linear function, a function is called linear if it has constant growth, meaning it has that constant slope. It can be put in the form y equals, my function notation, so f of x equals mx plus b. Alright, so it has a constant rate of change, meaning for every x value I have the same growth or the same decay if it's negative. We will get into exponential functions. That's 3.2, so that's the next section. So right now we do try to distinguish between the two. Exponential means it's changing at a percentage of its size. So it's not constant because the bigger it gets, the faster it grows. And so it's a constant percentage, which is the rate of change increases as the function increases. So it's not constant. An example of that, so the first examples are linear example. The second one is the exponential example. An investor deposits $50 per month in her savings account. Means every month the same amount goes in. Alright, in the first month it's $50. And in the 5th month, it's $50. So X months away, you're still going to add that many $50. And so that would be my slope. My slope would be 50. X would represent my months. B would be how much was the initial value in there at time 0 or month 0. And so this would be a linear equation, 50 times my months, plus if I started with something. B could be 0. They could have started with nothing in the account. But every month, they're going to add the same amount. So it's constant. It's a constant growth. Every month, they're growing by $50. Exponential means it's growing by a percentage of your value for that time period. And so an example, Bob's salary increases by 3% every year. Meaning every year, it grows by 3% of that year's salary. So each year, it grows by 3% of that year's salary. And again, that's important. So I'm going to do an example of this. Suppose that his salary started out at $100,000. All right, that's what it started out. So that would be, so the year 1, he would get $100,000. At the end of year 1, he gets a 3% increase. So his increase would be 3% of that, so you take your 0.03 times our 100,000, and so he would get to increase his salary by 300 that year. And so the next year, his salary would be 103,000. Then the increase would be 3% of that. So you would take your 3%, your 0.03, times the new salary, which was 103. And so it's a little bit, it's similar, but it's a little bit bigger. It's now 3,090 is the increase. And so then that next year, this would be the 3rd year, it would come out to be 109,090, and so you get that little bit more, right? So it's not constant. He's not getting 3,000 every year. Every year he's getting 3% of that previous year's salary, and so it's an increase exponentially because it increases based on the current value, all right? Which is different than linear. Linear, it stays the same. It's always $50. Never is any more than that. All right, so that's the difference between linear and exponential. Linear and exponential. All right, so I'm going to stop there. We'll get into linear functions and linear applications in the next set of notes.